Let's talk about absolute value. The absolute value of a number can be defined in a couple of different ways, one more intuitive and one which gives a formula for it, which is very useful for many of the things that we're going to want to do with it. So the intuitive way of thinking about absolute value is the following. The absolute value of a number A is the distance from A to 0 on the number line. The absolute value of A tells you, if you were to sketch out a number line and note 0 and note A, it tells this distance right here. And we denote this value the following way: the absolute value of A with two vertical bars on either side of A. And the point here is that it doesn't matter whether the number you're looking at is greater than or less than 0. The absolute value is always defined as the distance from that number, A or B here, to 0. In particular, the absolute value is never a negative number because negative distances don't make sense. The absolute value is always either positive or 0. So that's the first thing to note. That is, for any number A, the absolute value of A is greater than or equal to 0. The absolute value is never negative. So this is intuitively what the absolute value is, the distance from a number to 0. Another way of defining it is via a formula. And so this is the technical definition. The absolute value of A is, well, one of two things. It's either equal to A if A was already non-negative, and it's equal to the opposite of A if A is less than 0. Now, this notation right here is often confusing to people when first encountering absolute value, because the note that we have above says that the absolute value of A is always greater than or equal to 0. In particular, it's not negative, it's always positive or 0. But we have a negative sign showing up here in the definition of absolute value. But notice that that negative only shows up in the case that A itself was negative. And when A itself is negative, then the opposite of A, or negative A, is in fact a positive number. So this is in fact a positive number in this case. So we have these two different ways of describing the absolute value. There's one more way that we can define the absolute value, which is occasionally useful, and we'll see why in a later example. We have the following fact: if I take any number and square it, and then take the square root of that, that is always going to be the absolute value of A. Now, you'll notice that we're using the same notation here for absolute value as we used for the magnitude of a complex number. And there's a good reason for that. When you're looking at a real number, you could ask about its magnitude as a complex number, because any real number is also a complex number. And you can also talk about its absolute value. And the fact is that they are the same. The absolute value of a real number is the same as the magnitude of that real number, thought of as a complex number. However, we only define absolute value using that word for real numbers, not imaginary numbers. So let's do a few examples to see how this works. So if I want to know the absolute value of 5, well, I can use the fact that the absolute value is either going to be 5 or the opposite of 5, depending on whether 5 is positive or negative. Now 5 is positive, which means the absolute value of 5 is just 5 back. So when the input is positive, the absolute value doesn't do anything, or doesn't change anything. So absolute value of 5 is just 5. The absolute value of -7, on the other hand, this is the distance from the point -7 to 0 on the number line, and it's going to be 7. So when the input is negative, the absolute value changes the sign of the input. So the input was -7. The absolute value of that is just 7. The absolute value of 0 is just 0, and that's because the distance from 0 to 0 on the number line is itself 0. So what about the absolute value of something like x plus 1? Well, here's where we have to be careful, because the absolute value of x plus 1 depends on whether x plus 1 is greater than or less than 0. And that depends on whether, on the value of x. And so this is not something that we're going to be able to write down exactly what the answer is. We're going to write down two different possibilities depending on what's going on inside the absolute value symbols. So the absolute value of x plus 1 is going to be one of a couple of things. It's going to be x plus 1 if x plus 1, the input, is greater than or equal to 0, and it's going to be the opposite of the input. It's going to be the opposite of x plus 1, so negative x plus 1, if x plus 1 is less than 0. So when we're working with absolute values of expressions involving variables, then we've got two different possibilities that we can work out, that can come about there, depending on whether the input to the absolute value was positive or negative. And we're going to use that in a second when we talk about solving equations involving absolute value. All right, and for last example, let's look at something, an expression like 2 minus the absolute value of -17. When working on expressions like this that have to be simplified, we need to go through order of operations. And the absolute value symbols take the same precedence in order of operations as parentheses, meaning that you have to handle all the stuff inside the absolute values first and work out what that value is before doing anything else with it. So in particular, this 2 and the 17 can't currently combine in any way at all, because this -17 is being protected by the absolute value. Similarly, if we were multiplying by some number on the outside, then we couldn't just take it inside and combine them. We have to handle the absolute values first. So to simplify this expression, we first simplify the absolute values. Now the absolute value of -17 is 17, because -17 is negative, and so the absolute value takes the negative away and just gives back the positive 17. And now we have 2 minus 17. This is just a normal arithmetic step. So 2 minus 17 is -15, and we're done. So this is how we define and how we evaluate absolute values. Let's talk about how we solve equations involving absolute values. So let's consider the equation, the absolute value of x plus 1 equals 3. What this is saying is that the distance from the number x plus 1 to the origin is 3. Well, that means that x plus 1 could be one of two things. There are two numbers that have an absolute value of 3. We know that the absolute value of 3 is 3, and the absolute value of -3 is also 3. And those are the only two numbers that have an absolute value of 3. So if x plus 1 has an absolute value equal to 3, this means one of two things must be true. Either x plus 1 actually did equal 3, or x plus 1 equaled -3. These are our two possibilities. Because there are exactly two numbers whose absolute value is 3, and so x plus 1 has to be one of those. Now we can solve each of these equations for x to get that x is equal to 2 or x is equal to -4. These are the two possible solutions to this equation. So as a general rule, if the absolute value of a is equal to, let's say, some number k, then a is equal to k, or a is equal to -k. We do want to be somewhat careful here, though, because as we saw last slide, the absolute value is always greater than or equal to 0. So that means that if I look at the following example, the absolute value of x equals -1, this has no solution, since the absolute value of x always has to be greater than or equal to 0. So our general rule here, we can actually get a more precise statement than it. If the absolute value of a is equal to k, then the absolute value, then a equals k, or a equals -k, so long as k is greater than or equal to 0. If k is less than 0, then the absolute value of a equal k has no solutions. So the equation, for instance, like I have down here, absolute value of x equals -1, has no solutions. So let's look at a couple more examples where we use this fact in order to solve equations involving absolute value. So let's solve 5 minus 3 times the absolute value of 1 minus x is equal to 7 plus x. So when working with absolute values, typically your first step is going to want to be to, well, get rid of the absolute values and get yourself down into an equation that is more familiar. In order to do that, we're going to use the previous rule, where we know that if the absolute value of a equals k, then a has to equal either k or -k. But in order to do that, we need to get the absolute value term by itself. So step 1 is get the absolute value term by itself. using our normal algebra strategies of adding, subtracting, multiplying, and dividing both sides of the equation by whatever we need. So we want to get the absolute value term by itself. Let's start with subtracting 5 from both sides. If we do that, then we're left with negative 3 times the absolute value of 1 minus x, and that's going to give us 2 plus x. We'll divide both sides by negative 3 and get that the absolute value of 1 minus x is equal to 2 plus x over negative 3. Once you get the absolute value term by itself, then you can split up your problem into two separate ones. So from here, we get that if 1 minus x is equal to 2 plus x over negative 3, this means that either 1 minus x is equal to 2 plus x over negative 3, or 1 minus x is equal to the opposite of 2 plus x over negative 3. And now we can go through and solve these problems however we like. So in this equation, I'm going to multiply both sides by negative 3 in order to get rid of that denominator. Distributing the negative 3 through on the left, we get negative 3 plus 3x equals, and on the right, the negative 3's are going to cancel, and we'll be left with 2 plus x. So now we just need to solve for x. We'll subtract x from both sides to get negative 3 plus 2x equals 2, and then add 3 to both sides to get 2x equals 5. Divide both sides by 2 and get x is equal to 5 halves. So there's one of our solutions. Potentially, I'll talk about that in a second. Now on the right-hand equation, the negative on the outside of the fraction will cancel with the negative 3, so we'll just be left with 1 minus x equals 2 plus x over 3. We'll multiply 3 on both sides to get rid of the fraction, make things easier, and we'll be left with 3 minus 3x is equal to 2 plus x. And we'll go through the same thing. We'll get the x on one side, get 3 minus 4x equals 2. Now we'll subtract 3 from both sides and get negative 4x equals negative 1. And then divide both sides by negative 4 and get x is equal to 1/4. So here are our two possible solutions. However, when working with equations involving absolute values, we run into the possibility, we always run into the possibility that we have some extraneous solutions. Just like when we were working with radical expressions before, or rational equations. We have the possibility of going through the process, getting a number of answers at the end, a number of solutions, but some of them might not work. And not because we did anything wrong, but because the process we went through has the potential to run into those issues. So when you're solving equations involving absolute values, you need to check your work. So we must check our work. So let's see what happens. If x is equal to 5 halves, let's put that into the equation, and the original equation, and see whether we get a true statement. We get 5 minus 3 times the absolute value of 1 minus 5 halves equals 7 plus 5 halves. That gives us 5 minus 3 times. Now 1 minus 5 halves is negative 3 halves. And 7 plus 5 halves, if we add these Together, 7 is 14 over 2. So 14 over 2 plus 5 over 2 is 19 over 2. So we get 5 minus 3 times. Now the absolute value of 3 halves is positive 3 halves. So we get 5 minus 9 over 2 equals 19 over 2. And this is just incorrect. 5 minus 9 over 2 is a half, is 1 half. And 1 half is not 19 halves. So this shows us that actually 5 halves, while it came out of our problem looking, came out of our computations looking fine, is actually not a solution, and we can't use it. It's not a number that makes the absolute value equation true. And that's not that we did anything wrong, but it shows why we need to check our work. So now let's check x equals 1/4. That'll give us 5 minus 3 times 1 minus 1/4 equals 7 plus 1/4. And from here we get 5 minus 3 times the absolute value of 3/4 equals 7 plus 1/4. 5 minus 3 times 3/4 equals, now 7 plus 1/4 will be 29 over 4. Then we get 5 minus 9 over 4 equals 29 over 4. And this is also false. If you work out the left-hand side, the left-hand side is 11 over 4. And 11 over 4 is not 29 over 4. So in this case, we went through the process. We found two potential solutions, but unfortunately, neither one of those solutions worked. Neither one of those solutions were good enough to go into the original equation and give us a true statement afterwards. So in fact, this equation has no solutions. And this is something that comes up reasonably commonly when working with absolute values. Absolute value problems can have no solutions at all. Typically, an absolute value problem will have 0 solutions, 1 solution, or 2 solutions, sort of like a quadratic equation. The 0 solution case is actually pretty rare. Things have to sort of align just right for there to be, the 1 solution case is fairly rare. Things have to align just right for there to be only 1 solution to an absolute value equation. But having 2 solutions or no solutions is pretty common when you're working with linear types of expressions inside. So the next thing that I want to mention is one of the most common ways we use absolute values in applications, both in other areas of mathematics and in real life. And that's to talk about the distance between 2 numbers. So the distance between A and B is the absolute value of A minus B. So we'll use this a lot when we want to describe that 2 numbers are, say, they differ by exactly 3, something like this. One way of saying that is to say that their absolute value, the absolute value of their difference is 3. So let's see an example. So we'll say that the expressions x plus 1 over 4 and x plus 2 are have a difference of exactly 3. Find x. And there may be more than one solution to this. So for solution, we're told that the expressions x plus 1 over 4 and x plus 2 have a difference of 3, or the distance between them is 3. And we'll use this expression, we'll use this way of describing the difference or the distance between two numbers when we don't know which one is bigger. If we know which one is bigger, then we know how to subtract them so that we get a positive number out of it. But if we don't know which one is bigger, we don't know. So we have to write things down using these absolute values. So we want to know the solution to this absolute value equation. Now, there are a couple of ways of doing this. We can break up the absolute value into its two equations immediately, or we can simplify inside the absolute value first and then split things up. Both ways work just fine. I'm going to split things up first. So I'm going to write this as x plus 1 over 4 minus x plus 2 equals 3, or x plus 1 over 4 minus x minus 2 equals negative 3. And now we'll solve these equations. As before, I see that I've got a denominator here, and so to make things easy, I'm going to multiply both sides by 4. Now be careful when you do this that you multiply your 4 by all of the terms on each side. So when I multiply this 4 through the first equation, on the left-hand side, the x plus 1 over 4, when we multiply by 4, will just give us x plus 1, because the 4 we multiply and the 4 in the denominator will cancel. But the 4 times the x plus 2 will just stay as 4 times x plus 2, and then the right-hand side will be 12. And now we can go through the process. We've got x plus 1 minus 4x minus 8, distributing that negative 4 through. Now combining like terms on the left, we get negative 3x minus 7 equals 12. So we can add 7 to both sides to get negative 3x equals 19. And so dividing both sides by negative 3, we get x is equal to negative 19 over 3. So that's one of our possibilities. And now on the other side, we've got something that'll look very similar. And in fact, once you work out one of these problems, typically the other one will be very similar. So we'll get x plus 1 minus 4 times x minus 2 is equal to negative 12. And continuing on, actually working out this left-hand side is going to be exactly the same as before. So we're going to get negative 3x minus 7 is equal to negative 12. We'll add 7 to both sides, get negative 3x is equal to negative 5. Divide both sides by negative 3 and get x equals 5 over 3. So our answer here, well, first of all, we should check these numbers. For the sake of time, I'm not going to check them here. It turns out that in this case, both of these work. And so the solution set to our original equation is negative 19 thirds, comma, 5 thirds. And that's another way that we can use an absolute value equation. Now, occasionally we will run into an equation which involves more than one absolute value expression. So we may want to solve the problem, the absolute value of x plus 2 is equal to the absolute value of x plus 1, something like this. Now, there are a couple of ways that we can look at it. Let's see what happens if we just try to work out this problem using basically the techniques that we've had before. So we could say, well, we've got x plus 2, the absolute value of x plus 2 is equal to the absolute value of x plus 1. That means that x plus 2 has to equal the absolute value of x plus 1, or x plus 2 has to equal the opposite of the absolute value of x plus 1. And this is totally true. This is completely true here. But there are, of course, still absolute values in our equations. So let's rearrange those a little bit, or rearrange the right-hand one. What I want to do here is I want to multiply both sides here by -1. And in fact, I'm going to leave it as -1 times x plus 2. And that has to equal the absolute value of x plus 1. So now let's use the same fact again. Now each one of these equations we've got, which involves an absolute value, is going to split up into 2 more. So if the absolute value of x plus 1 equals x plus 2, this means that x plus 1 equals x plus 2, or actually let me write that down below, or x plus 1 equals negative x plus 2, or -1 times x plus 2. And then similarly over here, if the absolute value of x plus 1 equals -1 times x plus 2, that means that x plus 1 equals, well, -1 times x plus 2, or x plus 1 equals -1 times -1 times x plus 2. Just applying our rule twice. Now, we can, of course, simplify this last expression over here to get that x plus 1, in this case, would be equal to x plus 2. So we split up our equation twice, once using the first absolute value and once using the second absolute value. Now, what you'll notice is that there are 2 pairs of equations here that we got as possibilities that are in fact exactly the same. So in this particular type of situation where you have 2 absolute value expressions set equal to each other, we can actually simplify that expression pretty directly. So let's go to a fact. Let's state the fact, and then let's use it to solve this problem. So the fact that we want to use is that if the absolute value of A equals the absolute value of B, then A equals B or A equals -B. We don't have to consider all 4 possibilities, because when you do, then those possibilities have some repeats. So if the absolute value of A is the absolute value of B, the only possibilities are that A and B are actually equal, or they're opposites. That is to say, A equals -B. So let's look at our example again. Let's say we want to solve the absolute value of x plus 2 equals the absolute value of x plus 1. Well, this means that either x plus 2 equals x plus 1, or x plus 2 equals -x plus 1. Always make very sure to put parentheses around your expressions when you're putting a negative in front of them, because this negative has to distribute to all the terms inside. All right, so let's solve each one of these. So in this case, we can subtract x from both sides and get 2 equals 1. Now that's a problem because 2 doesn't equal 1. That means that we have no solution, but that only applies to this one possible line here. We had 2 possible equations to work with, indicated by the OR statement here. One of those possibilities, the left possibility, is never true. It's never true that x plus 2 equals x plus 1, so there's no way for the first equation to be true. The second equation is still possible though. X plus 2 equals negative x minus 1. So we can add x to both sides. Get 2x plus 2 equals negative 1. Subtract 2 from both sides to get 2x equals negative 3. And then divide both sides by 2 to get x is equal to negative 3/2. So there's a potential solution. Let's check our work. If we put negative 3/2 plus 2, and we want to claim that that's equal to negative 3/2 plus 1, well, let's work out what this equation says. So negative 3/2 plus 2, that's negative 3/2 plus 4/2, and then negative 3/2 plus 1 is negative 3/2 plus 2/2. So on the left here, we get negative 3 over 2 plus 4 over 2 is 1 over 2. And negative 3 over 2 plus 2 over 2 is negative 1 over 2. The absolute value of 1/2 is 1/2. The absolute value of negative 1/2 is 1/2, and so that checks out. So that tells us that we do in fact have a solution here. X equals negative 3/2 is a solution, is the only solution in fact to this equation. Now, as a final note, if your equation involves more than one absolute value, but it doesn't look exactly like this, doesn't exactly look like the absolute value of one thing equals the absolute value of something else, then you kind of have to go through the process that we looked at before, where we break it up into four separate equations to work with. So let's see an example of what that might look like. Let's try to solve the equation 2 plus the absolute value of x minus 1 equals the absolute value of 3x plus 2. So this equation involves two absolute values, but there's no way of rearranging it so that there's just the absolute value of one thing equals the absolute value of something else. And so our previous fact doesn't apply. To solve this problem, we're going to have to break it up into four separate equations, and we'll want to do that very carefully. So we'll look at, we've got that the absolute value of 3x plus 2 equals this expression over here. So from this, we can see that this means that 3x plus 2 is equal to either 2 plus the absolute value of x plus 1, or 3x plus 2 equals the opposite of 2 plus the absolute value of x plus 1. Now we've got two separate equations we're working with, each one of which has an absolute value in it, and that we can solve using our standard methods. Let's work out the left-hand one first. So we want to get the absolute value by itself, so we're going to subtract 2 from both sides. So we get 3x is equal to the absolute value of x plus 1, which means that we get that 3x equals x plus 1, or negative 3x equals x plus 1. So when breaking up your absolute values, remember to keep the stuff that was inside the absolute value the same and drop the absolute values, and then change the other side so that you either take the other side exactly as it was or multiplied by a negative 1. So solving each of these, not minus 2, minus x, we get 2x equals 1. Then dividing by 2, we get x equals 1/2. Over here, we'll subtract x from both sides, get negative 4x equals 1. Divide both sides by negative 4, and get x is equal to negative 1/4. And so that solves half of our problem. That solves the part of our problem that came from 3x plus 2 equals 2 plus absolute value x plus 1. Let's do the other side now. We get 3x plus 2 is equal to negative 2 minus the absolute value of x plus 1. Now we'll get the absolute value by itself, get 3x is equal to 2, is equal to opposite absolute value of x plus 1. I miswrote here. This is 3x plus 4 on the right is equal to the absolute value of x plus 1. We'll multiply both sides by negative 1 to get negative 3x minus 4 is equal to the absolute value of x plus 1. Now, you'll notice there are a bunch of negatives over on the left-hand side of this equation, but because it's got an x in it, negative 3x minus 4 could still wind up being positive if x is a large enough, if x is a negative number. So we still want to continue through our process, and if the absolute value of x plus 1 equals negative 3x plus 4, this means one of two things has to be true. It means x plus 1 equals negative 3x minus 4 exactly, or x plus 1 is the opposite of negative 3x minus 4. So we can solve each of these again. You can see that this process takes a little bit. Sorry, not plus 4x, but plus 3x. And we'll get 4x plus 1 is equal to negative 4. We'll subtract 1 from both sides, get 4x equals negative 5. Then divide by 4 and get x is equal to negative 5/4. And then finally, we've got our last OR equation to deal with. X plus 1 equals, now distributing this negative through, we get 3x plus 4. Solving for x again, we'll subtract 3x from both sides. We'll get negative 2x plus 1 equals 4. Now we'll subtract 1, get negative 2x equals 3, and divide by negative 2 to get x equals negative 3/2. So we managed to get 4 potential solutions to this equation. 1/2, negative 1/4, negative 5/4, negative 3/2. Now, we're not done, of course. In order to finish off the problem, we need to check each of these 4 numbers in the original equation. We need to plug those back in to the original equation, see what we get out of it, see whether we get a true statement or not. When dealing with problems involving multiple absolute values, you'll typically have a large number of potential solutions, but often some of them will be extraneous. So let's look at this. Let me copy our equation to another page where we're going to check. And our solutions were 1/2, -1/4, -5/4, and -3/2. So we're going to check all 4 of these numbers. So let's check x equals 1/2. We get 2 plus the absolute value of 1/2 minus 1 equals absolute value of 3 times 1/2 plus 2. That gives us 2 plus the absolute value. 1/2 minus 1 is -1/2. 3 times 1/2 minus 2 is 3/2 plus 2. So on the left-hand side here, the absolute value of 1/2, -1/2, is 1/2. And 3/2 plus 2 is 3/2 plus 4/2 is 7/2. Absolute value of 7/2. And this isn't true because 2 plus 1/2 is 5/2. The absolute value of 7/2 is 7/2. So that means that 1/2 is not a solution. Let's check x equals -1/4. We get 2 plus -1/4 minus 1 equals absolute value of 3 times -1/4 plus 2. So -1/4 minus 1 is -5/4, so we get 2 plus +5/4 is equal to, now 3 times -4 is -3/4, plus 2 is 5/4, because 2 is 8/4. And the absolute value of 5/4 is 5/4, and this is also clearly not true. So let's see, what about x equals -5/4? That gives us 2 plus -5/4 minus 1 equals the absolute value of 3 times -5/4 plus 2. So that's going to give us 2 plus -5/4 minus 1/4 is -9/4. And the absolute value of -9/4 is +9/4. And then we have 3 times -5/4 is -15/4 plus 2. 2 is 8/4, so -15/4 plus 8/4 is -7/4, and the absolute value of that is 7/4, which also isn't a solution. So lots of our possible solutions here are winding up not working out. Let's check x equals -3/2. From that we get 2 plus the absolute value of -3/2 minus 1 equals the absolute value of 3 times -3/2 plus 2. We'll get 2 plus -3/2 minus 1 is -5/2. The absolute value of that is +5/2. And then we get -9/2. -9/2 plus 2. 2 is 4/2. So -9/2 plus 4/2 is -5/2. The absolute value of that is 5/2. And again, we have nothing. So while it's very difficult to see just looking at the original equation, there's nothing about the original equation that would tip us off why this equation would have no solution. In fact, it doesn't. So all 4 of the solutions potential solutions we had failed to work, which can happen sometimes. But there was really no way for us to tell without going through the process of checking it. So this is another illustration for why checking your answer is so important when working with absolute value equations.